Welcome students in the organic chemistry lecture series. In this video we are going to study about the second type of stereoisomers, that is optical isomerism. Now before study about this optical isomerism, we need to learn some concept which are new for us, and in this video particularly we are going to study that concepts. Okay, so the first thing is that we will see what is optical isomerism. Optical isomerism is characterized by compounds having same structure. We can say these compounds have the same structure, but they have different configurations, different configurations, and they rotate. This is very important. They rotate the plane of plane polarized light. They rotate the plane of plane polarized light. So this concept is very important. What are optical isomers? They have same structure but they have different configuration, and they rotate the plane of plane polarized light. We will see what is plane polarized light later on. So we can say that they are optically active. Optically active. So the compounds which rotate the plane of plane polarized light are called as optically active compounds. So this phenomenon also we will see. Another important thing is that optical isomers have optical isomers have same chemical and physical properties. This is very important point, you remember, physical properties. Okay, but they differ, in their action on in their action on plane polarized light. Plane polarized light. So this point is also very important, that optical isomers have same chemical and physical properties but they differ in their action on plane polarized light. There are two types of optical isomers. We'll see first one is enantiomer, and second one is diastereomer. Diastereomer. So we are going to study in detail about this enantiomer and diastereomer in incoming videos. But today, in this video, in this primary video on optical isomers, we are just going to study about this concept. What is plane polarized light? What is optical activity? So these few concepts we have to understand first, and then we have to see in detail about this enantiomers and diastereomers. Okay. Now first of all, see what is ordinary light. According to wave theory, we know that an ordinary light has vibrations in all planes. Okay. So ordinary light is a light which has vibrations in all planes. Vibrations in all the planes. We can see all planes. So this light is called as ordinary light. But what is plane polarized light? That we have to see. What is plane polarized light? So you remember that plane polarized light has vibrations only in one plane. It is very simple. Ordinary light has vibrations in all planes, and plane polarized light has vibrations in only one plane. So when this ordinary light is passed through Nicol prism, Nicol prism, then the light which emerges out from that nickel prism is called as plane polarized light. Plane polarized light, and I have already explained what is plane polarized light. The light having vibrations only in one plane. Vibrations only in one plane. And that is also called as a monochromatic light. You remember this. Also, plane polarized light and monochromatic light both are same. So what is ordinary light? Ordinary light has vibrations in all the planes, and plane polarized light has vibration in only one plane. How plane polarized light is obtained? Plane polarized light is obtained by passing ordinary light through nickel prism. So the prism used for obtaining the polarized light is called as polarizers. Okay, so these are the some important basic concept to study optical isomerism. Another thing which we have to study is that what is meant by optical activity. What is optical activity? As I already told you that optical isomerisms have same chemical and physical properties, they have same structure, but they just have a different configuration, and due to different configuration they have different arrangement of atoms in the space, and due to this they have different optical activity. So what is optical activity? Optical activity is nothing but ability of compound to rotate the plane of polarized light. Okay, so the compound which rotate the plane of this plane polarized light are called as optical activity. If the compound is not able to rotate the plane of polarized light, then we call that the compound is not optically active. Okay, so for a compound to show optical isomerism, it must show optical activity. Okay, so we can say that the property of certain organic substance to rotate the plane of polarized light towards right or towards left is called as optical activity. So I will write here the property of organic compound. The property of organic compound to the plane of rotate the plane polarized light plane polarized light towards left that is anticlockwise or towards right that is clockwise. This property is called as optical activity. Okay, so which compounds are called as optically active compound? The compounds which can rotate the plane of plane polarized light are called as optically active compound. And as I already told you that for a compound to show optical isomerism, it must rotate the plane of plane polarized light either left or either right. It should rotate. And this rotation of plane polarized light towards left or right is called as specific rotation. You remember this? Specific rotation. Okay. So if the compound rotate the plane of polarized light towards uh, left then it is called as levorotatory compound. And if it rotate the plane of polarized light towards right, then it is called as dextrorotatory compound. Okay, so these are the few basic concepts which we have seen. So in this video we have seen about what is ordinary light and what is plane polarized light, ordinary and plane polarized light, how to convert ordinary light to plain polarized light, what is optical activity, what are optically active compound, all these things we have seen. So these are the basic concepts which we must understand before studying in detail about optical isomerism. So I think you have all understood this concept. So in next video we'll see in detail about optical isomerism. So have a nice day. Thank you.